Later on in the course, we're going to be adding an explosion coming from this dead mechanical creature on the ground here. So it helps for us to use some simulation techniques to get this creature to sprawl out on the ground nicely like this. You don't really want to model this by hand. I mean, you certainly could, but Houdini has some awesome tools that we can use to make this a whole lot easier. And it allows us to do sort of a blend between sculpting and simulation to make this a nicely art directable thing that we don't have to entirely model by hand to get it to just lay on the ground nicely like this. So going back into our scene, we can turn off the display for the disintegration and for the other flying creatures. And I'm going to add a new geometry object for this creature laying on the ground. Just call that creature ground and dive inside there. And then let's object merge in our creature model. So this object merge will point to object / creature / out creature. And for the viewport options, I'm just going to tell this to hide other objects so that we can only see what's in our current geometry object here. And we want to make sure that this creature is the same scale as the other creatures flying around the scene. So I'll just pin this viewport to creature ground here, and then I'm just going to go over to the creature flying simulated section. And we could do a reference to this transform here for the creature scale, or just directly copy that. And then I'll go back to creature ground, paste in this same creature scale here. And previously we had rotated this creature 180 degrees. In this particular case, it doesn't really matter if you do that or not. So I'll just leave the rotation alone so it keeps its original orientation and it just gets the correct size for our scene here. And next, let's bring in the low-res copy of our terrain for reference. So I'm just adding another object merge, point this to object, environment, out env low res. And if we template display that, you can see this just gives us this nice efficient low res copy of our terrain here. And then we can just transform the creature roughly into the correct position. In my case, I'm just using a transform sub to put him in this position right here next to the river, just because I want this explosion to be kind of close to the wide shot camera. So if you go back to the render cam wide here, you can see that this is in a pretty prominent position, so it'll show up nicely in our wide shot. So now zooming back in on our creature here, we're actually going to use the terrain as a collision object when we're sculpting this creature into place. Now we don't necessarily want to collide with this entire terrain. It's kind of wasteful to use the entire thing as a collision object. So I'm just going to use a bound sop to create a bounding box around this creature here. So let's put our display flag on the terrain and our template display on this bound. And I'm just going to add a large lower padding on this bound sop to make sure that it includes all the terrain below the creature's position there. And we'll just want to give ourselves a bit more room on all sides of this creature so we can splay out those tentacles a bit. So after the bound, I'm just going to add another transform sop and template display that new transform sop. And I'm using my Centroid transform preset. And we can just scale up the uniform scale here. You can do a bit of per axis scaling if you want to really dial in the size of this to make sure you have enough room to really spread out those tentacles. I think this will work just fine. And now that we've specified the area that we want to collide with the terrain, let's just do a Boolean on our environment. So drop in that Boolean sop. The environment will be the first input, and we're going to intersect that with the bounding box we just created, so put that in the second input. And we don't need to treat the terrain as a solid object. Just doing a surface Boolean on that's fine, so set the A input to surface, and the operation will be intersect. Then if you display the Boolean, you'll see that's just chopping out the terrain in the area around this positioned creature. So now that we have a shape for the creature to collide with, let's go ahead and create a soft body mesh for our positioned creature here. I'm going to start by just doing a VDB from polygons on this positioned creature. And we don't need this to be super high resolution. So dropping in that VDB from polygons, I'm going to try increasing this to 0.5 on that voxel size. And this voxel size of 0.5 is looking quite low resolution, so we'll need to reduce that voxel size a bit, but it will help if we look at the polygonal representation of this as we dial in that voxel size. So drop in a convert VDB, set this to convert to polygons and display that. And we don't need this to be very high resolution, but we do need to make sure that the tentacles don't turn into one big blob like we're currently seeing here. We need to keep distinct tentacles in order to sculpt them. So let's turn down our voxel size until we get some better shapes in those tentacles. Looks like 0.2 does the trick. Yeah, 0.3, they're still connected to each other. And actually, even at 0.2, they're still a bit connected there. So it looks like just under 0.2 is enough resolution to keep those tentacles from merging together. This looks all good, except for this one little spot here. So there we go. 0.15 seems like a good resolution for a decent proxy mesh here. However, this is a bit higher resolution than we really need for the sake of sculpting this creature's position. So after we do our conversion to polygons here, we can also remesh this to get a more appropriate resolution for our sculpting purposes. So on this remesh, I'm going to try starting with a larger target size of 1. And let's see what that looks like. And perhaps that's a bit too low res. Yeah, this target size of 0.6 on that remesh gives us what I think is a pretty good resolution for sculpting purposes. Now sometimes when we do this VDB mesh conversion like this can give us little disconnected pieces of the mesh, which we really don't want. And sometimes it's not very obvious if that's happening just by looking at the mesh here. So we can use a connectivity SOP to test and see if we're getting any disconnected pieces after that VDB polygon conversion. So if you drop in the connectivity here, this will default to creating a different class attribute value for each connected section of geometry. So if we look at the spreadsheet for that connectivity, and then we sort by the class attribute, you can see that we have values ranging from 0 through 4, so that means we have 5 distinct separate pieces here. However, most of this mesh is all going to be part of one large section like this, so we just want to keep the largest of these pieces. And you could do some sort of a manual selection here to isolate just the largest portion of the mesh. But it's a good idea to keep things as procedural as possible so that we don't need to change our selections whenever our input changes. And now to do a nice procedural selection to only grab the largest piece, I'm going to start by changing this connectivity here to, instead of creating a point integer attribute called class, I'm going to create a primitive attribute of the type string, and I'm going to call this name. So if you look at your primitive attributes in the geometry spreadsheet, you can see we have a different piece name for each piece of this VDB mesh. And now if we drop in a measure SOP, we can measure each piece individually based on that attribute. So this measure SOP will default to measuring the area of each of the polygons individually, but we can use this accumulate option to accumulate the area for each connected piece. So on this accumulate, set that to per piece, and the piece attribute is going to be name, and delete that class that was already in there. And if you look at the attribute spreadsheet for the measure SOP, you can see we have an area value for each one of these pieces. So for all the polygons that are part of piece 4, that has the same accumulated area for that entire piece. And you can see the same thing for 3, 2, 1, 0, although those areas are much smaller. So now that we have the area accumulated for each connected piece, we can isolate just the biggest section. And one way that you can do that is to pack the geometry with the pack SOP, and then we're going to pack this based on the name attribute. So just turn on that name attribute option, and under transfer attributes, we're going to select area so that the area values on the polygons are transferred onto the packed objects here. So now we have 5 packed objects, 1 object for each connected piece of our mesh, and we have the area value for each of those pieces here. And we can clearly see that this one area value is much larger than all of the others. But rather than just isolating that piece manually, I'm going to do a sort, and we'll do a primitive sort based on an attribute. So select by attribute here. And the attribute that we'll be sorting on is area. So if we look at the spreadsheet for the sort SOP and then click on the primitive number column here, you can see that it's sorting from the lowest values to the highest. But it's going to be a little bit easier to isolate the largest piece if we select reverse primitive sort. So it starts with the highest values to the lowest. And now that things are ordered from highest to lowest, we can just drop in a blast SOP, and for the group, we'll put in 0 for primitive number 0, select delete non-selected, and display that blast. So now we only have that one packed object with the largest area. And now that we just have the biggest piece isolated here, we can unpack our geometry. And then I'm going to add a null just to keep things nicely labeled. And this is our proxy creature. And now that we have our proxy creature mesh created, we can turn this into a soft body to sculpt that into place.